Bonjour et bienvenue Fully Charged. Coming this time from Versailles, which is just outside Paris in France, but this is actually an old army base in France, and what I'm standing in front of is in fact an induction charging strip. It's 100 meters of charged roadway, meaning that an electric vehicle can drive along here, and as it drives over this, it receives an electrical charge as it moves up to 110 kilometers an hour. So like going fast, like motorway speeds, it's still getting an electrical charge. It's amazing. Have a look. What you're seeing there, look, that's that van going over there. Oh, it didn't. Yeah, there it is, and it's getting a bit there. 25 kilowatts. Because this is like a test track, so it's not, you know, it's only 100 meters long. But each of those sections, you can really see as the van goes over how much power it's taking from the road, which is really intriguing. I mean, then this is really early stages experimental technology, but it clearly works. And what that would do is not suddenly charge. You wouldn't like go at the end of 100 meters go, wow, the battery's nearly full. What it will do is if that was a mile long.
Can we just clear the track? Because we're going to have a
high speed.
Fast run.
Fast run. We're going to watch a fast run. But what it would do is it means you wouldn't use any of your battery power. So that would extend how far you could go. That's the theory as far as I understand it. Yes, here he comes fast. He's coming fast. So watch here. And it also only switches on as the vehicle goes over it, so it wasn't
shy of 110 kilometers an hour.
110. So it was getting a charge at 110 kilometers an hour. It's pretty impressive. So what's under that 100-meter strip of road there is these, lots and lots of these in a row. This is the actual pad that's underneath the road. That's the transformer, which controls how much power goes into it, and also is isolating it in case of some damage or something. That means it won't, it's safe. It's all about safety. And then this bit here, this table shows the actual pads that are under the car. So this is what's under the car. There's two of these under each of the vans, and that is collecting the power as the car goes along. And I'm guessing now that's a box of tricks that's very important that it has to be in the car as well. There you go. There's a very, very technical presentation of it. So that is probably quite heavy. No, it's not. It's not heavy. It's very light. So that is what's got to be integrated into electric vehicles in the future, is something like that. That stuff is heavy and big and infrastructure. This stuff is light and transportable. So it's really exciting stuff.
So the specifications, the high-level specifications are here on the screen. Fundamentally, we decided to do 20 kilowatts to the car. The reason for that is because at 100 kilometers an hour, a typical EV will use something between 10 and 13 kilowatts to keep it going. So that means if we give it 20 kilowatts, it's going to charge the vehicle and keep it going at the same time. Obviously, at lower speeds, it uses much less power, so it can charge faster in a typical 50-kilometer road. The max speed is 120 kilometers. That's for motorway speeds typically. And the other concern from a practical perspective is how well do you have to be aligned to this thing to get charge. So we designed it to have plus or minus 200 millimeters of tolerance. Now, so don't really understand like what that means in practice, but our demonstration drivers are not using any sort of alignment systems for the demonstration today, and you'll see that they'll hit the road every time. So we found that the 400 millimeter wide track is easily achievable for a normal driver. On the tables over here, you'll see various components I'll be talking about. The front table has the vehicle pads on it. The vehicle pad size is very important to us. We wanted to keep it as small and cheap as possible, so they're actually fairly similar to a normal static vehicle pad that you would have at 11 kilowatts, 350 by 600 millimeters. And they're also compatible with a static charging. So that was another very important requirement. So they will charge on a static charger at 7.4 kilowatts, no problem. What's really important as well for cost of the whole system is the base pad size. So on the back table you'll see one of the base pads that we've got installed in the roadway that's in the trench next to you. That's about 450 millimeters wide, so it's designed to be as small as possible for the installation costs. The other important thing is, can you bury the pad? Because in practice in a motorway it can't be above the surface. We've got an air gap possible of 175 millimeters for this system. So this system is actually installed 6 centimeters under the ground and then transfers power to about 120 millimeters to the car, which is a typical normal car ride height. And it also allows then for asphalt to be put on the top without any problems. The frequency of operation is 85 kilohertz, which is a wireless charging standard frequency. So again, compatibility is really important.
So Eric, we've come in here to shelter from the rain, which is a great shame, but I've just seen for the first time a Renault Kangoo van driving along a road, charging as it was driving, which is a remarkable achievement. It's an amazing thing to see.
We are really proud. I think that Renault research team, in cooperation with many players like Qualcomm and Vedecom, have come to this very strong innovation. It's really a way to show the future of electric vehicle. We are not only talking about today the car for everybody that you can buy in Renault dealers, but also preparing the future. That's a big pride for us.
Because it's quite I think it was very well explained in the demonstration and the introduction that this isn't something we're going to see next week or next year, because the infrastructure is quite a big change, but the technology does work. I think that's
exactly. You know, when you introduce new technology, the first thing you have to show is that it works. Then you have a lot of additional questions that comes about the cost of the technology, about the scalability of the technology, about the investment, etc. But I think that what we have showed today is that this technology can work, that you can effectively drive 100 kilometers an hour and recharge basically the same amount of energy you're consuming for driving. So that's really a great step. And then this technology will compete with other technology to extend the range of electric vehicle, whether it is through bigger battery, whether it is through faster charging, and all those technologies are kind of competing for the next 10 years.
But it could also be a combination of all of them.
Definitely. And depending on the usage, depending on also the countries, because what is common with all those technology choices is that it's not only driven by purely the manufacturer who decide what he put in this car. It's an ecosystem, you know, and it's very interesting. If you look in Europe, you have 100 times more EV in Norway than in Italy, okay? Compared to the market. It's the same car, roughly the same customer. The only difference is that all that goes around the car is fundamentally different. And I think this example shows even more how important it is to bring together many players, including public authorities, to make those technological breakthroughs.
You're a vehicle manufacturer. From that point of view, it doesn't sound like, and I could be completely ignorant here, that it's a massive change to the vehicle. It's an additional, quite small component to the vehicle. I mean, this is aside from cost. Technologically, wouldn't it be that hard to integrate?
I would say from a hardware point of view, there is clearly define the space to put I would say the charger, and also to protect the car from all the electromagnetic questions that of course are very, very important. But no, I agree with you that the physical integration of the hardware is not the most complex thing. The big complexity is the connection between the car and the road, how sensitive it is to the way you're placed on the road. Is you're well centered. Of course, we cannot ask the driver to be perfectly aligned. Also, what happens when you have several cars on the same segment, etc. So there is a lot of questions, but the big question is not how feasible it is in a lab or in a prototype. The question is how cheap it can be to bring it in a large scale. And that's really the big question. And on this point, you have really some challenge also to face.
Because it's not so much, I would imagine, it's not so much the actual component, the charging pad itself is relatively simple, but to integrate that into the whole system is a huge cost.
Yes, and to make sure it works in all the conditions you can imagine.
Snow, rain, Mud.
Yeah. What happened when the car is fully charged,
Yes. Ooh.
for example?
Ooh, we hadn't thought of that. Never
It's
thought
fully
of that.
charged and
Yeah.
it brings
And it takes in more charge. Ooh.
what happened. No, so that's
Yeah.
it's we are in a research
Yeah.
mode. This is a kind of prototype of and it's the best way for us to learn and to put all those questions on the table and to make sure that in 5 years, 10 years, when
Yeah.
it goes in
Mass
wider,
production and- yeah.
we have solved all those questions.
Yeah.
So that's really
Yeah.
the goal of what you're saying today. It works,
Yeah.
and it helps us to raise all the questions.
Yes. Yeah.